Let's start with a broad view of a sarcomere, the functional unit of skeletal muscle. The sarcoplasmic reticulum is the site of the neuromuscular junction, where the neuron releases acetylcholine into the synaptic cleft, triggering the sarcomere to take in calcium ions. Actin is a thinner protein that ends in binding sites. Myosin is thicker and has small heads that fit into the binding sites of the actin. When the myosin heads fit into the actin binding sites and pull on the actin, the sarcomere contracts. This contraction is known as the sliding filament theory. Let's take a look at what's happening at the microscopic level. The myosin heads stick out towards the actin strand, ready to bind. However, they are unable to because the actin's binding sites are being blocked by a long string-like protein called tropomyosin. Troponin is another protein which pulls on the tropomyosin, opening the binding sites. When the troponin receives the calcium ions, it changes shape and pulls on the tropomyosin, opening the binding sites. Now the myosin heads can bind to the actin, making the distance between the two proteins shorter and contracting the muscle. The sarcomere decontracts when ATP binds to the myosin heads, releasing them from the actin binding sites. During rigor mortis, there is no ATP present, so the myosin and actin stay bound together.